I'm going to talk about research assessment today. Previous speaker touched upon the bibliometric distributions and how they are used. So I'll probably continue. I'll probably continue from there. So basically I'll talk about research assessment in general terms and then the bibliometric and scientometric measures used to assess the research, and then I will argue why we should be careful in using such metrics. This is not about my topic, but since yesterday you have been talking a lot about the this production of science. So I just wanted to put this slide up to see where Turkey is in terms of the number of publications, open access journals, how many journals included in Web of Science, how many of them are in DOAJ, Directory of the Open Access Journals, etc. Basically, we have about almost 400,000 articles, so we are in the 18th place in terms of the number of papers produced by Turkish researchers. I'll just point out that because it was discussed yesterday, we have about 278 journals listed in the DOAJ, but an additional 550 is hosted centrally in Turkey. Even though they use open journal system, not all of them unfortunately are listed in DOAJ. If they were listed in DOAJ, I'm sure Turkey would be much higher in terms of the number of journals. Now, research assessment has been based on what's called peer review. In other words, the works of scientists and researchers get evaluated by their peers. This has been going on for quite a long time. In the 60s and 70s, when we also wondered about the value of research in terms of economic impact, so OECD came up with economic indicators as well, like percentage of gross domestic products spent on research and development. They came up with the Frascati manual, etc. So that has been still continuing. In other words, peer review is still probably the most important evaluation method. We basically need research assessment to measure academic performance of researchers, to award tenure, for instance, to promote, but also to distribute research funds to the researchers based on their previous work and how productive they have been in their professional lives. So this is not new either. For instance, in the UK, this year they started using a new system called Research Excellence Framework, which is based not only on peer review, but also the use of bibliometric and scientometric measures as well. There are countries that use such measures to also distribute money to the authors of papers that are listed in the ISI indexes. Turkey is one of them. A little bit about bibliometric and scientometric measures. As I said earlier, even though the bibliometric distributions go back to the 1920s, as Professor before me said, they actually came into being when Eugene Garfield created what's called citation indexes in the 60s. A few measures were defined then. One of them is what's called journal impact factor. It was actually defined as a measure to help library and information professionals in collection development, so that they would know which journals to subscribe to, depending on how often the articles in those journals get cited by other researchers. It was not intended to measure the quality of individual articles, but rather the whole journal titles. As we have seen earlier, the distributions of, for instance, authors in terms of number of papers or the number of papers in journals, prestigious journals, they are all skewed. They are not normal distributions. Quality of a journal as a title, that it is not okay to judge the quality of an individual paper published in that journal title. Besides, the citation behavior quite differs from subject to subject. In technical and scientific fields, the number of citations is quite higher as compared to the ones in the social sciences and humanities. For instance, within a 5-year period, a paper, the best paper, for instance, or the highest number of citations to a paper in chemistry would get about 1,000 citations, whereas the top paper in economics would get only 60 within the same amount of time. I should also add that publishers' policies tend to change. For instance, in 2006, because of the competition from Elsevier, Thomson Reuters actually added a lot of titles from countries like Turkey, Croatia, etc. So suddenly, for instance, when Turkey had only 5 titles in the Web of Science, just overnight it went up to 70s. Now, of course, we can't really say that just overnight the level of science in Turkey jumped, but rather because of the Scopus's number of journal titles used for citation analysis, Thomson Reuters decided to simply change the threshold a little bit and accept local journals as well. So competition is certainly good. I'm not prepared to talk about this at this moment, but if you base your research assessment on the products of those competition, which is the case in Turkey, for instance, suddenly, because of the threshold is going down, you would have a lot of people actually becoming, let's say, associate professors, even though they may not necessarily deserve it. Now, a commercial company has every right to change the rules because they are only responsible to their shareholders. But if you're responsible for science policy in your own country, it's probably not very wise to actually base your decisions on the commercial company's decisions. Otherwise, later on, for instance, the same company might say, well, I don't care anymore about the threshold, so just include all of them. Why would then the science policy maker do? So I would argue that those measures do not actually measure the quality of individual articles, the quality of individual researchers, the quality of individual institutions or countries. Nevertheless, unfortunately, they get used very often for tenure, promotion, funding distribution, as well as publication support. Now, the other measure that has been in use since 2005 is what's called H-index or Hirsch index. I'm sure you are familiar with this. It's basically what counts is the area here. So in other words, you will have n number of articles with at least n citations. So if you have a, let's say, H-index of 10, it means that you published 10 articles which has at least 10 citations to them. But this part and this part, these are the ones that got very high citations. These are the ones below the H-index with very few citations that don't count in terms of your work. Now, what's the problem with the Hirsch index? Well, apparently the H-index actually doesn't meet some of the logical requirements, and according to the scientometricians, it's not a first-rate intellectual achievement, but rather a clever find, as Russo and his colleagues say. Even Hirsch himself admitted that in the original formula, co-authors are not taken into account. So if you write several papers with co-authors, your H-index could be much higher than the ones who like to write in solitude or single authorship. Besides, the correlation between peer review and H-index is not that high. It's about 0.6, but if you think about the impact and multiply it by itself, it means that it only holds for 1/3 of the articles or authors published, because if you square 0.6, this is what you get. So in other words, more than 2/3 of the variance in the data not explained by H-index. Also, the H-index tends to measure the, albeit incorrectly in most of the times, tends to measure the lifetime achievement of the researchers. It's not for short-term evaluation at all. Yet, we see examples where, for instance, there are some policies that state that if you want to become an associate professor, this is what your H-index should be. If you want to become a full professor, this is what your H-index should be. First of all, this is not a linear thing. It's one thing to have, an H-index of 5 with at least 5 papers having 5 citations. It's another to have, let's say, 7, because you had to really work much harder in order to collect that many citations. So such comparisons are just absurd. We all know that the patterns of scientific communication have changed within the last couple of decades. We are now more focused on the number of items that we publish, the number of citations we get, etc. This has not been the case, let's say, 30 years ago. For instance, here's an example. This guy, as you know, got the Nobel Prize 2 years ago, as Tatiana also mentioned yesterday. He says that today I wouldn't get an academic job. It's as simple as that, because currently academics are asked to simply churn out papers. How many of them? The more the merrier, as they say in the US. I checked his H-index, which is 10. Right now, if you ask the knowledgeable people who don't know much about scientometrics, perhaps, but they say, well, in order to get a Nobel Prize, you have to have an H-index of around 80. In fact, in the original article by Hirsch himself, he also calculated the H-indexes of the members of the American Academy of Sciences. Just recently in Turkey, they published all the Turkish researchers with H-index of 20 and over. It was a little bit lower for the women scientists, 15, and we had several of them. And the editorial said, well, we are very close to actually winning Nobel Prize because we have a very learned person in the United States, around 80, and according to this editorial, which is a science magazine, as if it is imminent that we would get a Nobel Prize in biochemistry. Now, the subtitle and the conclusion. You probably heard of the DORA statement a few years ago, chartered in San Francisco. In that document, it is said that the bibliometric performance indicators such as journal impact factor, journal citation half-life, H-index, etc., should be applied only as a collective group and not individually, and in conjunction with peer review, following a clearly stated code of conduct. This is the good, I guess, because right now there are countries where they don't base their research assessments solely on scientometric and bibliometric measures, but they do support their peer review with such measures. That's the way it should be. In fact, during their research excellence framework evaluations in the UK, the panel members were specifically asked not to take the journal impact factors and other measures into account when they evaluate the papers of the departments, because REF is supposed to distribute funds to the departments based on their production. However, we are increasingly seeing that these indicators, rather than supporting the peer review process, they tend to supplant the peer review process because it's easier to get from several commercial companies, including Thomson Reuters, Elsevier, Google Scholar, etc., and cheaper, I would say, because it takes time to actually, evaluate a certain number of papers, whereas you just click on a button and it says, hey, Yashar, you have an H-index of X. So this is the bad part. And here is the ugly part. Now, as I said, such measures shouldn't be used to evaluate individual articles, authors, institutions, and countries. Yet we see that we do exactly that. That is to say, we compare a scientist with, let's say, an H-index of 5 with the one with H-index 6. Now, if you have an H-index over a threshold, taking into account the variations in different subject disciplines, you might say, well, in his or her lifetime, this guy seems to be doing quite good. But in social sciences and humanities, if you have a very low H-index, how would you make such comparisons? Who are you to say that a social scientist with an H-index of 2 is, for instance, more valuable in terms of research he or she carried out than the one with 1? There are several examples of this. This is also true for science disciplines as well. Even within the science, the H-index of mathematicians is quite lower than, say, chemists. Because, the population of mathematicians, the potential number of readers of mathematics journals, the potential number of authors who would cite those papers is quite low compared to chemistry. It's very usual for a chemistry professor to publish, let's say, 5 papers in a year, whereas it's quite unusual to have a mathematician to publish 5 papers in a year. Or in fact, most mathematicians would probably publish 1 paper in every 5 years. I don't have the hard facts, but that's certainly the case. So it's wrong to actually make such comparison even within the same scientific disciplines, let's say science versus social sciences. So besides, there are some continuous studies where they try to predict who would win the next Nobel Prize next year by looking at the number of citations, as well as their H-index, as I have already said about the case in Turkey. So some researchers studied this. There actually exists no such correlation between how high your number of citations or H-index and whether you would get the next Nobel Prize. Now, I'm sure you have seen this before. It's attributed to Albert Einstein, but apparently Albert Einstein didn't say this. But anyway, it's a nice quote. It says, "Not everything that counts can be counted, and not everything that can be counted counts." This is exactly the case with bibliometric and scientometric measures. If you reduce this to bean counting, and falsely claim that you are actually measuring quality, you are doomed to failure.